All right, so can you guys see my screen now?
Yes, sir.
All right. So according from our conclusion, so the mean, median, and mode are all averages. However, they are not the same when it comes to the result. So it says here also that the mean is the most sensitive. Well, that is true because we are considering all of the data. Okay. And also, the median won't change at all because we are only trying to consider the middle one. So whether you change the smallest part or the largest uh, data, so it doesn't really matter as long as it didn't disarrange, okay, the arrangement of your data. Okay, so for us to see whether that one is true or no, so let's have this example. So in the bottom example, we compare the mean, median, the mode for the salaries of 5 employees of a small company. Okay, so we have companies 5 employees rather. Okay. Wherein we're going to get the median, the mean, and then the mode. All right. So again, for the mean, just get the summation and then divide it by the counts of theta. And then for the median, just arrange this one. So either from smallest to largest or largest to smallest. So either of those two. And then just get the middle number. And then for the mode, just get the most frequent numbers that occurs. Okay, so here's the solution for those three. So for the mean, just add all of those or get the summation and then divide it by the counts of theta, which is 5. So whatever is the calculation here is it already because it's right in there. So $506,000 divided by 5 because that's the count of data. Okay, and then we have a mean of 101,200. Okay, so this is for the mean. And then for the median, so just get the middle number. So first thing that you need to do is arrange this one into a rank list. So in here, it's actually already arranged. So this one is arranged from largest to smallest. So as you can see, the middle one is what? What is our middle number?
36,000.
36,000.
30,000. Okay, so I'm just checking if you guys are still there. All right, so as you can see, our median is 36,000. It's very far when it comes to comparing it with the mean. So from there, yeah, they are both average, but you know, sometimes having all of the results coming from those three methods are not that reliable. Okay, so in my case, I think the most reliable when it comes to getting the average is still the mean. Okay, median is I'm not sure. For some cases, maybe this one is useful, or more, maybe let's say more useful than the mean and the mode. But mostly, the most useful uh, way of solving the average is the mean. Okay, and then lastly, the mode. So just say that, yeah, right here, whatever is the most frequent number, that is already our mode. So as you can see, we have 20,000 in here. We're in it occurs twice or it occurs more than the others. So as a result, that is now our mode. Okay. So the data contain one extreme value that is much larger than the other values. So this extreme value makes the mean considerably larger than the median. And then most of the employees of this company would probably agree that the median of 36,000 better represents the average of the salaries than does either the mean or the mode. Okay, so that's the opinion of the employees. So I think even me, so I would go on this one on the median that this is the average when it comes to those salaries, right? Which is 36,000. So not 20,000, not 101,000, which is also super large, but only $36,000. All right. So as you can see, all of them have very different results, especially that we have a very extreme high value here, and then we have a very extreme low value here. So using the mean, median, and mode or comparing those three are not that satisfying. Okay. Anyway, so it's just that to show you that sometimes they are not that reliable when it comes to getting the average. But if you're going to ask me, I will still go with this one, with the mean, okay? Because it included everything. and then it divided by the counts of those every data, which is 100,200. So not that bad anymore. Okay, so our lowest is 20, our highest is 370. So I would say that this is pretty fair enough when it comes to getting the average. All right, so anyway, let's move on to the next one, which is the weighted mean. So this is just an advanced calculation or computing when it comes to getting the average. So we call that one the weighted mean. So a value called the weighted mean is often used when some data values are more important than the others. So let me give you an example. For example, you're always getting, ay, ganito lang. So let's say, okay, just wait a second, guys. Right, so really, I'm so sorry for that one. Oops, wait. All right, so let me give you an idea. So as you guys all know, the most important is the exam, right? The exam, the quizzes, and then let's say the sit works and then the assignments. So that's the arrangement. So let's say you're always getting a high score in quizzes and in let's say sit works. Did I say it correctly? Is the assignments and then the sit works. Yeah. So let's say you're always getting high scores on those two activity, but you're always getting a low score on the let's say quizzes and then the exam. So what do you guys think will happen to your grade? Did you guys understand what I
Make
have
it
said?
drop, sir.
Huh? Make it drop? All
Palalo ho.
right. Huh? So let's say you're always getting a high score in seat works and quizzes. So let's say high score. Let's say perfect score. Okay. But you're always getting a low score in quizzes and in your exams. So what do you guys think will happen to your grade?
Average.
Average? So of course you will get a failing score. Okay. Why? Because from here the competition in test or an exam is always 50%. And then 25% for the quiz, and then 25% for the seat works and quizzes. So let's say you've only got 25%, okay, but always having a failing score in tests and quizzes. So uh, no doubt that you're going to fail. But let's say you're having or you're getting a high score, say a perfect score in your exam, and then let's say low score on your quiz, and then also low score in your, let's say, average score of your seat breaks and quizzes. So are you going to, or will you be able to pass it if you have this kind of grading? Hello guys. So will you be able
Yes,
to,
sir. Yes, sir. 8 out of 10 yan.
all right, so probably, okay, because as you all know, the passing score in UC is 60%. So your test, the score is only 50%. All right. And then let's say your low score here, it's let's say 3% only out of 25%. And then your average score here is, let's say, oh yeah, you've already passed because this one is 12.5%. So half of it. So 12.5 plus 50 is 62.5, like 65.5. So that's already agreed up 80. Let's say 80 or more or less 80. So yeah, so in weighted mean, it's not just the count of numbers. So in some cases, some numbers are more important than the other numbers. Okay, so let's have a clear example. So, for instance, many professors determine a student's course grade from the student's quizzes and examination. So consider the situation in which a professor counts the examination scores as two quizzes scores. Okay. And then to find the weighted mean of the student scores, the professor first assigned each of the quiz scores a weight of 1 and the exam score as a weight of 2. Okay. So as you can see, uh, the exam is twice more important or twice the score of the quiz. Okay. So a student with quiz scores of 65, 70, and 75, and an exam score of 90 has a weighted mean of. So here's now the calculation part when it comes to the weighted mean. So here are uh, his scores in quizzes, which is multiplied by 1. Okay, so 65 times 1, 70 times 1, and then 75 times 1. So those are his quizzes. And then we have here 90 times 2 because this one is much more see, larger or much more important, okay, than the quiz, which is your exam. Okay, so as you can see, we are now considering the weight of the data, okay, not just a data itself. Okay, so we have 65, 70, 75, and then 90. So not just those numbers. So we are now multiplying them by its weighted or by its weight itself. Okay, so just do the math and then you will get 390 and then divide it by 5. So where is this 5 came from? So it is the summation of the total weight of the given number. So as you can see right here, we have 1, 2, 3, 4, and 5. All right. So it is not the count of the data anymore, which is 65, 70, 75, and the 90, which is only count of 4. But we are now getting the count of weight, okay, which is a total of 5. All right. So just do the math, 390 divided by 5 is equal to 78. So this is the weighted mean or the grade of that student if he has a grade of 65, 70, and 75 for the quizzes, and then 90 for the exam. All right, so this note is just telling us that the numerator is a weighted mean, above is a sum of blah blah blah, and then the denominator is the summation of all weights, which I already mentioned. Okay, so any questions so far?
Wala po.
So how's our pacing? Is it uh, fast? Is it slow? Or just right? Hello guys. So, Tagalog ko lang mabilis pa tayo or mabagal or sakto lang?
Bear brand, sir. Swak lang.
Ito lang.
Patawa talaga tong si Miss De Vera, no? May lagi kang hugot eh. Okay, sige. Sakto lang daw, sabi niya. So, I
Wala
hope.
naman bebe yan, sir.
Ano yun? Ha?
Sir, wala daw. Wala, sir.
Alright. So, I hope to the others, sakto lang din. Bear brand lang din daw, sabi ni Miss De Vera. Okay. So, I hope uh, sakto lang talaga. Okay. Hindi masyado mabilis, hindi masyado mabagal. Anyway, so here's the main technical definition of the weighted mean. So the procedure for finding the weighted mean can be generalized as follows. So the weighted mean of the n numbers, so let's say x of 1, x of 2, x of 3, up to, let's say, how many numbers is that? Let's say up to 100, with the respective assigned weights of weight 1, weight 2, weight 3, up to the maximum number also of your uh, data, okay, or a least number. So in here, as you can see, every data has an equivalent weight. So x1, this is its weight. For x2, it is this weight. x3 is 1, and then so on and so forth. Okay, so it should be multiplied by its equivalent uh, weight. Okay, so every data has an equivalent weight, especially if they are coming from different categories, like for example the one that we had before, the quiz and then the exam. Okay, so weighted mean is equal to the summation of close and open parentheses x times w, okay, divided by the summation of the weights, right? So again, your divisor here is the summation of your weights, not the count of your, or not the counts of your data anymore, okay? Where summation of x times w is the sum of the products formed by multiplying each number by its assigned weight, and summation of w is the sum of all weights. All right, so I hope this one is super clear, and I think you guys will not be having a problem here since this one is super straightforward. All right, so let's have another example for you to be able to appreciate this weighted mean. Okay. So many colleges use the 4-point grading system wherein we have A plus, A minus, and so on and so forth. So A is equal to 4, D is equal to 3, C is equal to 2, and then D is equal to 1, and then F is equal to 0. So we call this one actually 5-point, am I right? 5-point grading system. Anyway, I'm not sure because we've never used this one in my school before. So is there anyone here who was able to up 4-point? So that's why 5-point? 4-point grading system. So is there anyone here who used 4-point grading system before when they were, I don't know, maybe elementary or high school or even senior high? Is there anyone or not? 5, 4, 3, 2, 1. So I think all of
Wala, sir.
us, yeah. So I think all of us uses the normal way of, you know, showing the grade. Like uh, 75 is the passing score, and then the highest one is 99. But in here, I think, I'm not sure. Maybe F is the completely 0, and then B is maybe failing grade, and then C is the passing score, and then B is like 80 to 89, maybe, not sure. And then A is probably 90 and above. Okay, so that's how they say they grade, or that's how they calculate the grade. So using a 4-point grading system. So some are A plus, A minus, and so on. So it's quite confusing. So find the weighted mean. The table below shows Dillon's fall semester courses grades. So use the weighted mean formula to find Dillon's GPA for the fall semester. So as you can see, Dillon's has 4 courses here. Let's say 4 subjects rather. And then here's their equivalent or corresponding grade. So for English, he has a grade of B. For history, he has a grade of A. And then chemistry has a grade of B. Then algebra is C. Okay. And then each of those subjects, of course, has a weighted mean. So meaning it is the count of units. So in other schools, okay, the more units of your subjects, the more important it is. Like it will affect your calculation of grade. But in UC, it doesn't really matter. So let's say you have 3-unit subject or 1-unit subject. So both of those subjects are still equal. Okay, because of course in UC, ano ko ba sasabihin? So when it comes to calculating your grade, maybe I would say that, let's say you have a grade of 99 on a 1-unit, and then let's say 75 on a 4-unit subject. So it will be still calculated the same. Okay, it doesn't really matter when it comes to units. But maybe for this one, 4-point grading system, so course units or the count of units matters. So this is where they measure the weight of that certain subject. So as you can see right here, it's like English is much more heavier compared to the history and chemistry also. Okay, wherein they only have 3. And then algebra is also much more important than those 2. All right. So yeah, that's We give an example. Anyway, so let's solve for the weighted mean of this one. So again, just get this one wherein b is equal to 3. So 3 times 4 plus a is equal to 4. So 4 times 3 plus b is equal to 1. So 1 times 3 plus c is equal to 2. So 2 times 4. So it is now the summation divided by the summation of weights, wherein the weights here is the course units. So 4 plus 3 plus 3 plus 4. 4, 8, 11, 14. So whatever is the summation of what we've calculated before, so just divide it by 14. And then that's already your weighted mean. Okay. So for you to be able to understand the one, so we have here the solution. So I'll give you guys a minute or 2 minutes to understand this one and then check whether the calculation is correct or not. So as you can see right here, the loans GPA for the fall semester is 2.5. Wherein if we are going to look back that one in the 4-point grading system, 2.5 is around here, B or C. So I don't know, maybe B minus or C plus. So I don't know how they uh, calculate that one. So just let me know once you guys are done in analyzing this one solution. Or if you're confused, so feel free to ask me anytime. All right, so is there anyone who's confused? Or did you guys all get it?
Gets.
All right, that's good. Coming from Mr. Dan. About you, Mr. Vera, Mr. Pierre, Mr. Gotim. Yeah, Mr. Gotim.
McDo, sir. Nuggets.
All right, that's good. How about you, Mr. Ian and Mr. Emilio?
Gets, sir.
All right, that's good. So I'm not sure that the others who didn't answer, maybe they're doing something. Anyway, so right after your example, you're going to have a quiz, of course, which is super similar with the past example. Okay, so we have here like same concept, just a different name. So Dylan became Janet, and then uh, her courses now has more than Dylan. So we have five subjects, and then here's your equivalent grades, and then the equivalent weights or course units. All right. So I'll be leaving this one to you guys. So next one is frequency distribution. Okay. So this one is like one of the most realistic, okay, data that we can have when it comes to calculating for these statistics. Why? Because we now have a raw data. Okay? So mostly when it comes to raw data, it's not only ranging from uh, 50, it's actually more than that. So mostly it's like 100, 200, 300, or 400. But for the sake of, easier understanding, so of course, we're only going to use 5, 10, 15, 20, 25, 30, 35, 40. 40 counts of theta only, okay? Because 100 or 200 is too much. Okay? So just for the sake of example, we're going to use 40, okay? 40 counts of theta. So when we say raw data, it is the data that have not been organized or manipulated in any manner are called raw data. Okay, so it's fresh, right? So a large collection of raw data may not provide much readily observable information. A frequency distribution, which is a table list of observed events and the frequency of occurrence of each observed event, is often used to organize raw data. So as you can see right here, yeah, like if we have 5 numbers only or 5 data, so we can observe it easily. But if we have raw data wherein it's ranging from 50 and above, okay, we cannot easily observe what or how do we get the say arithmetic mean, the weighted mean, the median, the mode, and so on and so forth. Okay, so that is why frequency distribution is used on this kind of data. So we call that one frequency distribution. So how is this frequency distribution being used or being uh, made? So table below is the frequency distribution of table below. Okay? Table above rather, this one. So a frequency distribution is like this. So we have a title here where in this one or this column is the observed event, number of laptop, computer X, and then the frequency number of household F with X laptop numbers. Okay, so as against right here, here's the first column wherein we have the observed event number of laptops, and then this one is the total of population or the total of data, wherein we have here the frequency of laptop computers. So the main idea here is just arrange them, okay, or just get the minimum count of data. So as against right here, we have 0. And then we have 7. Okay. So just list that one from 0 to 7. Okay, just like this. 0 to 7. So 0, 1, 2, 3, 4, 5, 6, 7. And then from here, count the what do you call this one? Count the data, okay? How many times it occurred. Let's say 0 here, 0 here, 0 here, and then 0 here, and then here. So if I'm not wrong, we have 5 zeros. So it occurred 5 times. And then for 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12 ones. Okay, so we have 12 ones. So as against right here, we have here the event number and then the frequency number of that event number, or the corresponding event number of that data. So this row indicates that there are 14 households with 2 laptop computers. Okay, this one has 3 households wherein they have 3 laptops. This one has 2 households, are I mean 2 computers wherein in 4 correct 2 households, okay, 2 households wherein they have 4 laptops, and then 3 households wherein they have 5 laptops, and then 0 households wherein uh, there's 6 laptops, and then 1 household wherein there's 7 laptops. Okay. So from here, we're going to get the frequency wherein if you're going to add those, we have a total of 40. Okay, so here's the number of household, and then here's the count of laptops on each of those households, right? So the formula for a weighted mean can be used to find the mean of the data in a frequency distribution. So the only change is that the weights, weight 1, weight 2, weight 3, and so on and so forth are replaced with frequency 1, 2, 3, and so on and so forth. So this is illustrated in the next example. Okay, so as you can see right here, going back to this one. Okay, so instead of using the frequency, we're going to use now the weighted mean, because in this one, instead of considering this one as the weight, we consider this one now as the frequency. I mean, the other way around. Instead of considering this one as your frequency, we consider this one now as the weight. So again, am I correct, or just the other way around? The other way around. Sorry, it should be the frequency. Okay, not the weight. Sorry, it's now quite confusing. Anyway, so when it comes to distributed frequency distribution, okay, so we use the f variables instead of the weights. All right. So as you can see right here, we have the summation of frequency and then the summation of frequency below. All right. So to get the mean, we have here the summation of x times f, and then the summation of frequency, which is already given here, which is 40. So from here, it started from starting from 0 up to the 7. So just list all of those. So this is the first one. So 0 times 5 plus 1 times 12 plus 2 times 14 plus 3 times 3 plus 4 times 2 and so on and so forth up to this part. So just do the math, okay, divide it by the total frequency, which is 40, then you will get this one. So 79 divided by 40, okay, then you will get 1.975. So it's like saying that the average count of laptops on each household is 1.975. So some of them, so not really 1.9 series. There is no 0.975 laptops. So we can consider that this one is 2. So mostly, or in every household, there's 2 laptops. Okay? So that's the average count of laptop in every household. Okay. So again, I repeat, so this one is quite similar with the last one, the weighted mean. But instead of using the, where is that one? Instead of using the W as your symbol, we're going to use the frequency. Okay. So yeah, so kind of similar. Okay. Just the symbol. Okay. So any question or clarification so far?
None, sir.
All right. So how about the others?
Sir, wala ako.
All right. So if you have a question, so ask me on the part 3 since we don't have a time anymore, since I think we only have 50 seconds. So just reserve that one for the part 3. But before we end this one, okay, so you're going to have, of course, as usual, you're going to have a quiz after this example, okay, which is similar with that one. So here's the frequency, and then here's the count of data, or the x, or the data itself, right? So again, see you after 5 to 7 minutes, since we still need, or I still need to convert the recorded video. All right, so goodbye for now.
Bye, sir.
Goodbye.